Hey, g'day, it's Presso. Thanks for stopping by. Now I'm starting a new project today. It's going to be a metal casting and metal machining project, and it's to make a bracket to go onto this beautiful George Thomas universal pillar tool with the optional sensitive drill head. I believe you can still buy the castings for this from Hemingway Kits, and there was a book that was published which has all of the detailed drawings and the build notes as well. Now let's have a closer look at the machine, and I'll show you some upgrades that I've done just in the last couple of days. That were things that I never actually finished, and some things that made a huge improvement to the appearance of the machine. So let's have a closer look. So here's a close-up view of the universal pillar tool. It's also sometimes called the tapping and staking tool. Now this was described in the Model Engineer magazine back in the mid-1970s. I believe Hemingway Kits still make a set of castings for this tool. And the way it works is that you've got this upper arm here with a lock on it, and you can fit all sorts of accessories into that arm and lock them in position. So this one here is for small taps, and it holds the tap perfectly perpendicular to this work surface down here. There's also one for larger taps and things like countersinks, and it's got the high leverage handle on it as well. There's an accessory for holding things like letter stamps and number stamps, and they're just held in place using a spring-loaded system, and once that goes in there you can lock it, and will keep the letter or number stamp in the same orientation every time. So if you mis-stamp it, or if you don't stamp it deep enough, you can just give it another tap and control the depth of the impression. There's also a collar which can be used for things like punches, so center punches or like pin punches and so on. Once again, it goes in there and you can lock it. So it is very versatile. I recently fitted ball handles to this machine. These were left over from another project and I'd never used them. So I've repurposed those for this machine here. They've all been Parkerized, so they're not going to rust. And there's also an indexing system on the table here. Now this was another thing that I didn't finish when I made this machine back in around about 1987. So with this accessory here, you can do direct indexing. There are 60 holes around the outside of that table there, and this little spring-loaded plunger can be dropped into any one of those 60 holes, and then there's a lock underneath for the table, so that won't move even with the spring taken out. I'll just put the sensitive drill head on now. We'll have a close-up look at that. So again, it just slides down the column here. This is specifically designed for very small drill bits, sort of like number 80 up to number 60 or bigger. I think this drill chuck will take up to 1/4 of an inch, but you probably wouldn't want to use drill bits of that diameter in this machine. So it gets its name as a sensitive drill press or sensitive drill head because you're acting directly on the end of the spindle when you drive the drill bit down. So there's no rack and pinion, so you get a better feel for what the drill bit is doing. Now again, one of the accessories I made just in the last couple of days is this micro adjustable stop here. So it's got a little screw underneath there, and that can control the depth of the drill bit. But there is another collar here which is like a direct stop which can act against the top of this 2-step pulley here. So that's actually working with the micro adjustable stop there now. But I can slide that collar down and lock it in place, and that gives you a more definite stop on the spindle. But what we need to do is get this casting made, which is currently sitting on the back here as a 3D print. Let me show you that. So this is the part that we want to make as the casting. So let's go and have a look at the material and the pattern. So this is the pattern that I want to use to make this bracket. So it's a very straightforward pattern. It doesn't need to be a split pattern. There is actually draft angle on all of the surfaces below this top flat part here. This is just 3D printed in PETG plastic. It's been filled and painted with an automotive paint. So yeah, fairly straightforward sort of pattern to use. But the metal I want to use for doing this is this stuff here. Now this is called ZAMAK, Z-A-M-A-K. Now the letters stand for zinc, aluminium, magnesium and Kupfer, which is German for copper. Now at almost 95% zinc, it's very, very heavy. This ingot here is 10 kilos. I don't need all of this, so I'm going to cut it into 3 parts and I'll just use this end, and even that will be more than I need. But curiously, this material has another name called ZAMAK, and it was coined by a company in New Jersey, USA back in the 1920s. Now the name ZAMAK became sort of universal sometime later, and that's now the more common name. But if you do hear it called ZAMAK, it's basically the same stuff. Now, I believe this stuff is very user-friendly. If you're doing home casting, it's got a low melting point. It leaves a great surface finish after it comes out of the mold. But what I'm interested in is to find out whether you can electroplate this. But at, say, 95% zinc, it should be possible to zinc plate it. And after that's done, I can use a post-passivating process to change the colour. So I want the scene to come out black when it's finished. And I've got a black chromate that we can use on zinc plating. So that's going to be one of the goals with today's project, is to see if we can do that. Anyway, I'm going to get this cut up and then we'll make a mould. I forgot to mention that this ingot here was donated to the channel by a very kind viewer named Philip Dimon. He got in touch with me and said he was buying some and did I want some. And I said, yeah, I'll have 2 10-kilo ingots. And I sort of said, yeah, I'll help you to pay for them. But he very kindly donated them. But he wanted me to tell you that if you're looking to buy this here in Australia, you can get it from a company called Hayes Metals. I'll put the URL on the screen there now. They don't have an online store, but you'll be able to get in touch with them and tell them you want some. And evidently it goes under the name HM12 here in Australia. So yeah, if you're interested in getting some, you may be able to find it from that source. Rightio, let's go. Don't you hate that? So just for fun, I'm using K-Bond sand for this mould. So K-Bond is an oil-bound sand. It's a bit like Petrobond. And again, this material here was kindly donated to the channel. I don't use it often, but in this case, I may not get to pour this mould today. And it means I can leave it overnight and it won't dry out and go crumbly. So that's probably the only reason I'm using K-Bond. It does behave quite differently to green sand. It takes a bit of getting used to. I find it's a bit more sort of doughy. I always hated getting to this point, and then you've got to say to yourself, where I'm going to put the metal in and where's going to come out. It's just total guesswork on my part. So the thickest part of the casting will be here. So I'm guessing that's where you want the riser to be. And I don't know how much this material, this ZAMAK, shrinks. Alright, I think I'm going to put the metal in there. Yeah, right, do that there. Okay, well that's way more straightforward than any of the previous molds I've done recently. If you watch my series on doing the Cleveland model race cars, it's just like a walk in the park compared to that. Cleans up really easily. It's just a nice stuff to use, this K-Bond. I don't know why I don't use it more often. The only thing is it makes a huge mess on your hands, but that's okay, that'll clean up. So I'll close this up, and I think we've got time to do this today. Well, everything was going so well, and I've had my first setback, so that big chunk of material is not going to fit into my crucible. It's a number 8 crucible. Even if I was sort of just jam that in there and put it in the furnace, there's every chance that the weight of that would just crack the crucible. So I'm not going to risk that. I'll cut it into 3 more pieces and I'll go from there. Yeah, big chunks, aren't they? I'm just getting ready to do this casting job. And a while ago I did a video and a viewer got in touch with me and he was absolutely horrified that I was wearing a pair of dirty old sneakers while I was pouring metal. And he very kindly sent me this set of firefighter boots. Now these are steel capped. They come right up above your ankle, and once you put your cups over the top of that, there's no way that you're going to get metal down inside those boots there. And these are brand new. And I had a look at them, and I looked at the quality, and I thought these got to be worth at least $300 or $400. So it's a very kind offer, and I do appreciate it. I did actually go and buy another pair of shoes just recently. These have actually got composite caps, so they're very sturdy as well. The thing I like about them is they've got a zip on the side, so it's a lot easier to get in and out of them. But these firefighter boots are unreal. They're still very stiff. I haven't worn them very much at all. I just tried them on. And also have the zip in the front. It is actually a bit of a mission to get them on. Oh, also sent me these gloves. And again, these are firefighter gloves. Probably made of Kevlar or something. But yeah, these would be great. Thanks. Okay, that seemed to go okay. The thing was, I was messing around trying to find the batteries for my pyrometer and I couldn't. And this stuff melted way quicker than I expected. So I had no idea what temperature I poured that at. It should have been between 400 and 420 degrees C. But it seemed liquid enough, flowed in there really well. Still molten. So I guess we're okay. Yeah. It's just one of those things that I'm used to pouring aluminium and I know how long it takes for it to melt, and I just wasn't prepared for how quickly this went. Alright, see how we went. Looks kosher. Alright, I'm calling that good. It's excellent actually. The only thing is, that was left in the pattern, that little hole where I put the screw in. Well, that's okay. That'll actually probably be drilled through anyway. Well, I just cooled that down and cut the gates off. The casting itself looks pretty good. Can't get over how heavy that is, but that's okay. In this application, it doesn't matter. But it's certainly very user-friendly. Just filled the mould, no trouble at all. And what we need to do now is get to the mill and actually clean up this top surface here. And we need to bore it out and drill a pattern of 4 holes there, and those holes will be counterbored later on to mount the motor. And then this back face here, at the moment, that's not square, that's got some draft angle on it, so this will need to be squared up, and I think I'll do that in the shaper just for fun. And then we're going to see if we can electroplate this. If I can't do that, we'll powder coat it. But yeah, so far, happy days. Before I can machine this part on the top surface, which is the big flat surface you can see here vertical at the moment, I need to create 2 parallel faces on both sides of this casting. So I've just set that up in the vise with a square, and it looks pretty close. So I'll go ahead and machine this just to clean it up, and that's all. I can rest that on the bottom of the vise now and do the other side. That sure does machine nice. What we're going to do now is grip this in the vise, confident that we're gripping on 2 accurate surfaces. I'll fly cut the top surface there. Then we can bore out for the motor mounting and drill all the holes. To get this part level in the vise, I just touched the tip of the fly cutter against the surface here and zeroed Z on the DRO. I moved to this end, did the same again, and tapped it in. It was only out by about 50 microns, so it should be fairly level now, and we're just going to skim the top. Okay, that's pretty nice. What I need to do now is use the touch probe with touch DRO, find the centre of that bore there and machine that out. Okay, I've just centred up over that rough cast hole there. I'm actually accurately centered between the jaws, so whatever bore we make now will be exactly on the center line in the Y direction, and with the rough cast bore there I've just got as close as I can in the X. That should be the correct bore size now to fit over the mounting on the end of the motor. So just go do a pitch circle diameter now of 45.8 and drill through and counterbore for the screws that hold the motor on. Okay, that's fine. Oh, damn it. Okay. I was hoping I'd be able to drill through that little depression there in the casting, but yeah, it's not going to happen. Okay, I'll deburr everything there, clean it up, and then we need to machine this end here. This is the underside of the casting, and the way the pattern was made, this surface should be flat. There's no taper in that at all, but I do want to clean that surface up because the flange of the motor butts up against this face here, so we'll do this in the shaper. Okay, that's cleaning up really well, but I'm a bit worried that the clapper box is going to hit this vertical part here. So I'm going to reconfigure this and give myself a bit more tool stick out. And we'll just go a little bit further and take a slightly deeper cut down here. Yeah, well, that went deeper than I wanted it to, but not by much. We'll just feed back the other way. Well, that does machine really nicely on the shaper. Yeah, beautiful. Okay, need to clean up this this other end now. Well, this is not the ideal setup. This vise is quite shallow, so I've got a little machinist jack underneath this projecting surface here to stiffen that up a bit. Only going to do very light cuts, and we just need to clean up that surface, and that's all. That'll make that square to the previously machined face. Well, there's something deeply satisfying about using a shaper. That surface finish is excellent. Alright, it's got to have 3 holes drilled in it to mount this onto the back of the sensitive drill head arm. Got the part set up in the mill vise now. It's resting on a parallel, and in order to find the center in X, I've used this wiggler. Now these are great because they reach down a long way, and the parallel section on the casting is from about there down. So I can reach beyond that point and zero on that edge and find center that way. And I've got to drill a pattern of 3 holes in the casting, and I've got exactly the same pattern in the arm of the sensitive drilled head. And I had to retro drill these because the original holes that I drilled, I wasn't sure how accurate they were, so I've enlarged these to M6. So we'll do the same here, and they'll be countersunk holes. Okay, I'm all set up here now. This is going to be a problem with getting enough reach to drill right through this part. So this is a 4-facet drill, so it should make a clean start without needing a spot drill. And this is the hole that's closest to this surface at the back here. The other 2 are a bit further out toward the front. But I think I can just make it, but countersinking these holes is going to be a bit of an issue, but we'll see how we get on. Okay, okay, I just made that, but I still got a countersink. I think I'm going to have to make an extension for my countersink to be able to do this. And if you're wondering, I can't use regular cap head screws because the motor body is too close to the surface of the bracket. Well, I had to go away and make an extension for one of my countersinks and it just fits. So I'll go ahead now and countersink all these 3 holes for these M6 countersunk head screws. Either that's blunt or this material tends to build up on the cutting edge. I'm not sure. Anyway, I've got another countersink, I'll swap it out. Well, just missed all the action there, I forgot to turn the camera on. But that went okay, the screws fit now down flush with the surface, so that's all good. I'll take this out now and try it, but yeah, I wish you'd seen that, it worked brilliantly. Well, there's the finished cast and machined ZAMAK bracket fitted to the back of the drill head now, and this has turned out to be way more solid than I thought it would be. It's just, there's no chance that's going to bend or break. So I'll get the motor mounted on there now, we'll fit the belt and we'll run a drill bit in it, and I'll show you a couple of other enhancements that I've made to the overall design. So stand by. Got these lovely cheese head screws, slotted screws. These are vintage items that came with the motor. By the way, this motor came from an old Gestetner ink duplicator. These are really common in secondary high schools where I used to work. They were, you know, big, heavy industrial machines, but you could almost guarantee if you use it, you'd come away with black ink all over your fingers and your hands and your clothes. Well, there it is all assembled, and you'll notice that I made a 3D printed rack for all of the accessories now, and I fitted one of these little LED work lights here as well, and that's just got a magnetic switch on it. That just brightens up the work area, and it's all back together, it's all cleaned, and it's working. So let me show you drilling a hole now. This is a 1mm drill bit, so we'll do that, and then I've got a rather embarrassing story to tell you. That's just some thin 80mm angle, so let's see how that goes. It's just really nice to be able to feel what the drill bit is doing and knowing that you're not overloading it. And that's running on the highest speed. So yeah, I'm super happy with the way that's worked out, but let me tell you this rather embarrassing story, because it's a doozy. Now, I'm not sure if I mentioned this at the start of this video, but this motor here was originally mounted down where this one is on the baseboard of this machine. Now, I've actually cut this baseboard down a bit because I don't need the size that I had before. And the motor drove with this pulley here on the main spindle of the motor itself, and it came up via a very long belt and around this pair of jockey pulleys which were mounted where the motor is now, and that drove the main spindle. And I guess you can see where this is going. But when I took this motor and I turned it through 90 degrees and mounted it like that, that's right, it's now driving the spindle in the wrong direction. So what would have happened if I kept the direction correct would have been to lift the motor up and have it inverted, driving the pulley that way. But that's not what I did. And when I was testing this off camera, I just put a very small drill bit in there. I got my stock on the drilling machine table, and I tried drilling a hole, and I thought, you know what, that drill bit must be blunt because it's not cutting. So I swapped it out, tried a different drill bit, same thing happened. I did it 3 times before the penny dropped. And I felt sick because I thought, I've gone to all this trouble and I've just completely ruined the whole concept. Now, in the back of my mind, I thought maybe I can just reverse the direction of the motor And when I had a look, sure enough, there are actually 4 wires coming out of this motor, which means that the start winding and the run winding are separate, and that means that you can reverse the start winding and that will reverse the direction of the motor. So by the skin of my teeth I got this to work, and yeah, it was a near thing but anyway, it's all going now and I'm very happy with the result. Now in the next video I want to have a go at electroplating this ZAMAK casting. Now the reason for that is I want to do another project involving ZAMAK castings that are going to get polished and then chrome plated. But in this case I want to put a zinc plate on this material here. Now the only problem is that from what I've read, you cannot electroplate directly over any zinc based castings. Now you might say, well that's weird, why can't you zinc plate zinc castings? The problem is that this also contains copper and magnesium and a few other elements, aluminium for example. So you can't electroplate directly onto the ZAMAK, but what you can do is a thing called a copper strike. Now, copper strike is just a very thin layer of electroplated copper, but the electrolyte that you use is an arsenic electrolyte, also called arsenic copper. Now doing that at home is just about impossible, but I do have a product called Ultra Strike. It's an alkaline based electrolyte, and from what I read you can use it on these ZAMAK castings. So I'm going to have a go at that. Once I've got the copper strike on there I can use zinc after that. Once we've got the zinc plate we can use a passivate treatment. Now I've got 3 different coloured passivates. There's a blue, a gold and a black. But I want to do this casting in black, so that's what I'm going to do next. So I'm going to invite you to come along and watch that. Could be a fail, but I think it's worth trying. If it all goes badly I'll just sort of clean it all off and we'll leave it as it is. Now the only problem with this ZAMAK is that it does oxidise and eventually goes grey. So I think it's going to look nice if we can get a zinc coat on that. So that's where we're going next. So I'm going to ask you to come along and watch that. I've got some wildlife footage to show you today, and come back next time and enjoy the electroplating. It's Prezzo signing out for now. Cheers. This is a juvenile kookaburra digging for food. Threw some bacon scraps out the window before, and they usually swoop down straight away and eat them immediately. This little juvenile here is begging. Looks like mum's not going to give it to her. You lost your breakfast, mate.